Hi, we're going to be talking about calculation of rate of interest today. Uh, I've already mentioned that there are three ways in which you could calculate the rate of interest in any financial deal. One of the most popular methods is the trial and error method, although it's a lengthy method. However, it gives you a lot of conceptual clarity in terms of relationship between rate of interest and present values and future values. Another simple way of calculating R is using Microsoft Excel and typing out a rate formula, RATE, fill in the constructs, and the formula gives you an answer for the rate of interest involved in the deal. But let's try out the trial and error method over here. Uh, for example, let's say we are talking about a loan arrangement. Let's say I want to buy a car. The cost of it is 15 lakhs. I don't want to borrow that amount entirely. Let's say I do a down payment of 3 lakhs, and the loan that I am taking from a bank is worth 12 lakhs, right? And the bank says that this loan is repayable by paying an annuity of 2,75,000 per annum, and the time period involved is 7 years, right? So the deal is that you borrow 12 lakhs from a bank right now, and you agree to pay 12 lakhs 75,000 over a period of 7 years, and it's a yearly installment. Now, provided the details of the deal, what are we interested in knowing is the rate of interest, because when we compare one deal with another, from one financial institution or bank with another, we are interested in knowing what is the rate of interest that the bank charges. Now, through the basics, we know that the loan formula which is applicable is the present value interest factor of an annuity formula. So let me put it up in an equation for you. We know this equation, we've gone through it, that present value is equal to annuity into PVIFA at some x rate of interest for a period of 7 years. What we have is the present value, which is 12 lakhs. We also have the annuity, which is 2,75,000 into an annuity factor. What we don't know is this rate of interest, right? Now, the trial and error method involves assuming X percent. Let's say we assume 10%, 11%, 15%, so on, and trying to check that are we close to 12 lakhs. We want an amount which is more than 12 lakhs, and we want an amount which is less than 12 lakhs, so that we get to know that the actual rate of interest lies between these two rates. So let's try this out. Let me assume that x is equal to 10%, right? I want to check 12 lakhs is equal to 2,75,000 into PVIFA at 10% for 7 years. So let me try this out. You know that the formula is 1 minus 1 upon 1.10 raised to 7 divided by 0.10, right? So if I work on the annuity factor, what is the annuity factor that I get for a 10-year period? So I get 4.868. So 275 into 4.868 gives me a value of 13,38,815. And if you observe and compare this 13 lakhs with 12 lakhs, the answer is way more than 12 lakhs. Now, when I said that the trial and error method helps in terms of conceptual clarity, what I meant is this, that you will now be forced to think that what is x? It certainly is not 10%. The next question that you've got to ask is this more than 10% or less than 10%? Now, suppose I were to jump from 10 to, let's say, 15% as an assumed rate, what will happen to your answer? Will it be 13 lakhs? Will it move to 15, a higher amount, or will it go to a lower amount? Now, obviously your r is there in the denominator, it is 1 upon 1 plus r, and if I change this from 10% to 15%, clearly my present value will go down. So that's bit of logic that we've got to understand, that what is the next rate that I assume. I don't assume 8%, because if I assume 8%, the amount will grow from 13 lakhs to 14 or 15 lakhs, and we are already above 12. We don't need an amount above 12. I want to go below 12 lakhs, and in order to reduce this value and in order to go below 12 lakhs, I will have to assume an R which is more than 10%. So let me do this, let me try this out. Let me assume R equal to 14%, right. So it is 2,75,000 into PVIFA at 14% for 7 years. That's 1 minus 1 upon 1.14 raised to 7 divided by 0.14. So that's 4.288. That's your annuity factor. So 2,75,000 into 4.288 gives you 11,79,283. So when your rate of interest goes up to 14 from 10, your present value falls from 13 lakhs to 11,79,000. So there is an inverse relationship between rate of interest and present values. When the rate of interest goes up, present values go down, and vice versa. There is a positive relationship between rate of interest and future values. When the rate of interest goes up, future values tend to go up. That's a basic fundamental understanding that we've got to have whenever we are working on the trial and error method. Now, I have one value which is below 12 lakhs, so 12 and 1179, slightly below 12 lakhs, and I have one value which is more than 12 lakhs. So, I am very convinced that my actual rate of interest is lying somewhere between 10 and 14. I can do an interpolation and look at the actual R which lies between 10 and 14. But I am a little bit uncomfortable with a 4% gap between 10 and 14. So let me do this. Let me try and pull down this 13 lakhs, get closer to 12 lakhs. So I don't want to assume 10% over here. Let me try and assume a rate which is below 14 but not as low as 10. Why am I doing that? Because I want to close down the gap between 10 and 14. So let me assume this to be, let's say, 12% instead of 10%. If I rework this saying R is equal to 12%, then I have 2,75,000 into PVIFA at 12% for 7 years. And I keep my fingers crossed that I'm still going to get an answer above 12 lakhs, 4.563. So 275 into 4.563 is the annuity factor. That comes to 12,55,033. So the target value that I wanted on the LHS was 12 lakhs, all right, and I have one answer which is more than 12 lakhs, one answer which is less than 12 lakhs. I can therefore conclude that the actual rate of interest on this deal is somewhere between 12 and 14. Let's do some simple math now. If I were to say rate is to present value, at a rate of 12%, the present value that I got was 12,55,033, and at a rate of 14%, the present value that I got was 11,79,283. right? Let's do a delta or a change. For a change of 2%, the change in the present value is 1255,033 minus 1179,283, which gives me 75750. So when my rate of interest changes from 12 to 14, my present value changes from 12 lakhs to 11 lakhs. Basically, a 2% change results into a 75,750 change. What is the target value that I am looking at? I was looking at a present value of 12 lakhs, which lies between 1255 and 1179. Now let's assume I was at 12, standing at 1255, and from 1255 I want to move to a target value of 12 lakhs. What is the delta required from 12 lakh 55,000 to 12 lakh? I require a delta of 55033. So if I want my present value to change by 55,000, what is the rate of interest in terms of delta that I need to look at? So let me do a cross multiplication. 55,000 into 2% divided by 75, 55033 into 2 divided by 75750, that gives me 1.453%, right? So if I want to bring about a change of 55,000, I need to change my rate of interest by 1.453%. Where was I standing? 12. You know your answer is between 12 and 14. So do I add 1.45 to 12%, or do I deduct 1.45 from 12%? Obviously I add, because your answer lies between 12 and 14. So your R is going to be 12 plus 1.453. Basically R is 13.453% per annum, right? So the bank is offering you a rate, this R comes to 13.453%. That's the rate that the bank is offering when it gives you an EMI of 275 and a loan of 12 lakhs. So you've got to assume two rates in the trial and error method. No matter which formula you are using, try and get as close as possible to the target value, whether the target value is a present value or it is a future value, depending upon the formula that you are using. And as I said, try and close down. I took a 2% change. A 2%, 3% delta will more often than not give you a very accurate value of the rate of interest involved. So I hope this kind of makes the trial and error method clear. We could be using several formulas, future value, annuity, single cash flow, but the process of guessing the rate of interest remains the same. Let's now move on to another concept, which is about the word effective rate of interest. Now, when we approach financial instruments and financial institutions in the market, the way they present the deal to you, a financial deal, could be very different, and it could cause a lot of confusion. What do I mean is the following. Let's say we have two offers, one from bank A, which says that if you deposit 1 lakh with us right now, we offer a rate of 12% per annum compounded quarterly for a time of, let's say, 5 years, right? So that's the deal from the first bank, that if you want to put up an FD for a 5-year period, the offer is 12% per annum compounded on a quarterly basis. When you go to bank B, the deal changes. Bank B says, all right, the amount remains the same, 1 lakh, and the offer is, let's say, 12.75 12% per annum compounded annually. So this bank offers a quarterly rate of interest. This bank offers an annual rate of interest for the same time period, 5 years, right? Now the question is, which is a better deal? And you can't get across this by just comparing the rate of interest, because you've got to compare two equitable rates of interest. 12% is compounded quarterly and 12.75% is compounded annually. You can't compare a quarterly rate with a annual rate, or let's say if this 12.75% was compounded semi-annually. You can't compare a semi-annual rate with a quarterly rate. So one way is, do not compare the rate of interest, compare future values. We know this formula, that future value is equal to present value into 1 plus R by M raised to N into M. So your present value is 1 lakh, rate of interest is 12%, and if it's quarterly compounding, M would be equal to 4, because you would get interest 4 times a year. So divide by 4, 5 years into 4. So that grows to 1 lakh into 1.03 raised to 20, right? So 1.03 raised to 20 into 1 lakh results into 1,80,611, right? So that's what you get at the end of 5 years if you put up a fixed deposit with this bank, which offers quarterly compounding. With bank B, there isn't quarterly compounding, so your formula remains 1 plus R raised to N, that's 1 lakh into 1.12, that's 12.75%, 1275 raised to 5, right? So 1.1275, that gives you 1,82,214. When you compare these future values, you get to know that 180 is what you get and 182 is what you get. So essentially, annual compounding at 12.75% is better than quarterly compounding at 12%. So this is one way of getting to it. However, as we just calculated, we require 1 lakh and we require 5 years as an input variable to calculate the future value. Suppose you don't have this data, or a lot of us are wired in terms of thinking about a rate of interest R, and we are okay with comparing R across financial options available or businesses available. If you are wired to think in terms of a rate of interest, then this calculation doesn't appeal to you. I want to compare bank A's effective rate of interest with bank B's effective rate of interest. And why am I using effective? Because this is 12%, you're getting 180. Had you calculated a simple 1.12 raised to 5, right? 1.12 raised to 5 gives you 1,76,234. What is this calculation? This is 12% compounded per annum, and this is 12% compounded quarterly. In quarterly compounding, you effectively get more money than annual compounding. So although the stated rate of interest, and this is a word that I want to introduce, the stated rate of interest is 12%. But what you get effectively is more than 12. You don't get 1,76,000. What do you end up getting is 1,80,000. So what is written and stated by the bank is 12%, but what you get is effectively more than 12%. Hence, I am interested in knowing that what is the effective rate of interest over here in this deal. And what I can do is, I can calculate the effective rate of interest with the help of this formula, that effective rate is equal to 1 plus the stated rate divided by m, the whole raised to m minus 1. Let me plug in the values. 1 plus 0.12, 12% is the stated rate. Since it is quarterly, m is equal to 4 raised to 4 minus 1. So what I get is 1.03 raised to 4 minus 1. If I solve that, I get 1.1255 minus 1, which comes to 0.1255. In other words, 12.55% per annum, and I need to write this 12.55% per annum compounded annually. So I have converted 12% per annum compounded quarterly into 12.55% per annum compounded annually. In other words, I would be indifferent in getting 12% on a quarterly basis or getting 12.55% on an annual basis. Now, when I compare this 12.55 with this 12.75%, which was also compounded annually, I am now comparing apples with apples, an annually compounded rate with an annually compounded rate, and it's a very clear decision that bank B offers me a higher rate of interest, 12.75, vis-a-vis 12.55 that bank A is offering. I could not have compared 12% quarterly with 12.75%, and hence if I wanted to, if I am wired to think in terms of a rate of interest, I would compare 12.55 with 12.75. So the reason you calculate an effective rate of interest is because you want to convert a quarterly or a monthly or a semi-annual rate into a annually compounded rate in order to compare across options. I hope that makes the funda of effective rate of interest and stated rate of interest absolutely clear.